Hello, welcome to Kitchen Chemistry. Go away, sorry. Just as I go to start, it's a time for my entire family to come in the kitchen. No, we're good. Put the compost outside, you're fine. Welcome to Kitchen Chemistry. My name is Brianna, and as always, I am your host, and I am here to guide you through some sweet kitchen experiments today that you can do with all materials you have at your home. You don't need to buy anything. So, we have been doing kind of a little series on classic kitchen experiments, and today is the last day of that series. So we did the last 2 weeks, we did strawberry DNA extraction, cool, and we did some Elkins toothpaste yeast enzyme experiments. This week, we are going to talk about density, which is a really important topic from chemistry that has to do with physics, it has to do with ocean science, it has to do with how your body works, it has to do with temperature. Density plays a role in lots of different processes in the world, so it's super important, which is why we're going to talk about it today. So what is density anyway? So density is how much mass an object takes up by volume. What does that mean? I just added 2 more words to the thing. So we already talked about what matter is. Matter is anything that occupies space and has mass. So I'm matter, you're matter. You can see my brother took the long way to get to the compost. We can still see it through the window. Sorry. We already know that matter is something that takes up space and has mass. So mass is kind of like weight, if we want to think of it that way. But weight can kind of fluctuate because it's how hard gravity is pulling on you. So you weigh a different amount depending on how much gravity there is. So you weigh a different amount on the moon than you do on Mars, than you do on Jupiter, than you do on Earth. But your mass always stays the same. That is kind of how much matter you have. So an object that is more dense has more matter by volume than an object that is less dense. So it's sort of like if I had the same amount of mass of like lead and feathers. The lead, because it's more dense, would be a smaller visual amount, even though it was the same weight as something like feathers, which I'd need to have, like if I had to have a pound of feathers, it would be a ton. It would take up a lot more space than a pound of lead, which is a really, really dense substance. So density has to do with, again, a lot of different processes in the world because density plays into everything, whether it's a solid, a liquid, or a gas. And pretty much everything on Earth is made of solid, liquid, or gas. There is plasma. We're not going to talk about it because it's complicated, and I am not a chemist, physicist, or meteorologist. So we are denser than things like air. Gases are normally less dense because they take up a lot of space. There's lots of space between the particles by their volume. So to have like a pound of oxygen would be a lot. It would require a lot of space as opposed to a pound of flowers or a pound of stone, like my table, or a pound of corn syrup or a pound of hair or t-shirts. It all, depending on their density, will have a different volume. So what we are going to do is we are going to do 2 experiments. One is to kind of show the density of different objects, and one is to show how density can play into making stuff, which is fun. So, what do we got on the materials list today? Let's go to the table cam. So, table cam, ignore how messy my kitchen is. So, what do we got? Water and a measuring cup. We have a couple different cups. Today, I recommend a tall, clear one. Apparently, I don't own a tall, clear cup, so this one's got a little grady lines on it. You want something tall, reasonably the same circumference all the way through. It's a little tapered, but that's okay. And relatively clear so you can see. I have milk, dish soap, corn syrup, a backup cup, because you know this is, as we talked about last week, this is the handy dandy at-home test tube. My sippy cup, because I need water while I talk. Vegetable oil, doesn't matter what kind. And I have some nail polish remover, along with food coloring, tried and true, and some random objects. So I have a little bolt, I have a cherry tomato, and I have a popcorn kernel, just for fun. And then I also have something fizzy. Now I'm going to talk about our fizzy things in a little bit because they're less relevant to the first experiment, but muy importante for after. So I already mentioned that a lot of different substances have different densities, and often different liquids do too. So if we think of something that's like a thick liquid, so one really viscous that moves really slow, instead of kind of spreading out, it kind of oozes. If we think of something like molasses, it's pretty slow, it's pretty thick. That is typically something that is more dense, whereas something that flows really easily, or like water, is going to be less dense because it's more runny. Now, here's a thought. If I have pancakes and I have some maple syrup in my fridge, and it's been in my fridge, so it's kind of cold, it's pretty viscous, but I put it on those hot pancakes, all of a sudden it's running everywhere. Why is that? Well, heat and temperature actually plays into how dense something is. Because when we apply heat to molecules, they get more energy. It's kind of like if we compare me in the winter to me in the summer. When it is winter, especially in Victoria, because we have gross winter, where it rains and it's gray forever, and the leaves are dead and gross, I don't have a lot of energy because I'm cold, and I don't like being cold. So I stay in my house and play video games, and I'm not doing a lot of moving. Whereas in the summer, it's warm, it's nice outside, I have a lot more energy. It's like I'm taking my dog for a walk, we play at the park all day, we do lots of things, I'm moving, I'm grooving, I'm excited. That's kind of like particles and how they react to different temperatures. So molecules in an object, when more heat is applied, they vibrate. Just like this. Even with solids, you might think like gas, when heat is applied, they have a lot more energy. Like gas already, there's not a lot of, the particles are really far away. That's why I can kind of move my arms around it, and I'm not like whacking something, but we can still feel a little bit of resistance. Those are the air particles, or the molecules rather. When the heat is applied, it expands. Same with liquids. When heat is applied, it expands a little bit. And solids even expand a little bit too. Even though solids, the molecules are normally like really close together. It's kind of like if you're in a crowded elevator, really squished together, that's like a solid. Well, crowded elevator pre-COVID. Gas is more like post-COVID. We're all really far apart. So when heat is applied, they move around a little bit more. So with things like maple syrup on my pancakes, when it's cold, it's more viscous, it's more dense, so it moves more slowly. But when heat is applied via the pancakes, our syrup, our liquid, the molecules inside it spread around more, they have more energy, so they're able to move faster. For example, I took my car to the shop one weekend. That's always an experience. But you actually should check your tire pressure in the summer and the winter, because if you set your tire pressure, my tire pressure for my car is 32 psi. Doesn't matter the units. It's 32. In the summer, it was all the way up to 40 because the gas inside my tires actually expands because it's hot. It takes up more space. You actually have to lower the tire pressure. And then in the winter, it's going to be low again. I'm going to have to put air in it. It's just a vicious cycle. But another example of heat and density. I'm going to start doing experiments now and stop flapping. A little excited. So what are we going to make? We are going to make a classic. We are going to make a density tower. So I'm going to use some specific fluids because these are the fluids I easily had accessible in my house. But your house is not my house. Mi casa is not su casa. So you're going to have different liquids. So you're welcome to experiment. You're welcome to try things out. I want you to experiment. That's the whole point. So I'll show you a demo, but try your own way if you don't have the same stuff. That's awesome. So this is where we want to use our tall cup. So I'm going to layer, hopefully, some different fluids and objects inside of this cup based on their density, with the most dense being on the bottom and the least dense being on top. So I gathered all these ingredients and I guessed what is the most dense. So we are going to do this experiment together. So if it doesn't work, we're going to learn something together. So cup cam. There we go. First thing, we're going to do some corn syrup because as we can see, it's pretty thick, it's pretty viscous. I think it's pretty dense. This is going to be the grossest cup to clean later, and I'm going to have so many regrets. But there is our corn syrup. Blech, it's already sticky. Oh, barf. Okay. We can see We want like a nice layer of our substance here so that you can easily see the density difference. So we did our corn syrup. Now, what do we think is more dense? The next one, I have soap, I have oil. I think we're gonna go with this soap. So as you start layering them, just like 2 weeks ago, when we made our strawberry DNA experiment and we extracted it, and I asked you to be very careful pouring the alcohol on top of the strawberry juice, there's another example of density, because the rubbing alcohol, is less dense than water. So what about water sinks to the bottom as long as it's not disturbed too much, the alcohol will float nicely on top. So in order to layer these nicely, you need to pour them carefully. So this isn't one where I want to go just jab it in there. You want to gentle, patience, careful. I know I don't exhibit a lot of care and patience, but we're going to try together. So, taking our soap back to the desk cam. So I am going to run soap down the side. We're going to do a liberal amount of soap until we start seeing separation station. Oh, it is working! Sweet! Okay, I guessed right. So now we can see, because corn syrup is more dense than the soap, da-da-da, the soap floats in a layer on top, and they don't mix together. Kind of neat. I want to see if I can add food coloring to it, because it's going to be easy to see. It's going to look cool. I'm going to use green. Green seems like a soapy color. I'm going to very gently. Do you need to use food coloring? No. But you've all met me at this point. I like food coloring. Mostly just like color. That's why I'm going to, ooh, that looks kind of neat. Kind of sinking. Do you see that? It's trying to sink. Ooh, sorry. So I'm going to give it the gentlest of stirs so that we can see the colors better. I'm going to use this knife. Nice kind of butter cheese knife. It's got a pointy end without actually being sharp. And yes, you do need to stick your tongue out. It definitely helps. Got a green. It's green adjacent. I'm going to stir two down because I don't want to mix the colors. But, kind of looks like alien snot. Isn't that fun? So, okay, we have our first two layers done. Next up, we are going to try some vegetable oil. Vegetable oil of choice for me is canola oil because I come from the prairies and gotta love our canola. So again, we are going to carefully pour this down the side, gentle like. I hope this is less dense. Yay, it is. Sorry, nothing was riveting. Woo! My face of concentration. Sweet! Okay, that worked too. Awesome, awesome, awesome. We're crushing it so far. So, again, da-da-da-da. Our canola oil is yellow, but we have corn syrup, soap, canola oil. Let's keep going. Let's do some water. I'm going to dye this water pink because I like pink. I'm a scientist who love the color pink. I like glitter and sparkles and unicorns and all that jazz because scientists can like whatever they want. So, sorry, I had some people tell me that scientists can't be girly before, and I am like the girliest girl on the face of the planet. I put on glittery eyeshadow before I teach on YouTube, and I'm a scientist. I wear whatever I want. But if you don't want to wear that, that's fine too. Little scientist rant for you. Just rinsing off the knife because I don't want to have to clean 8,000 dishes when we're done today. Yeah. What you don't see at the end is me cleaning everything I own. Yeah, tip of red to this just so it's a little more fun. Okay. Got our water. we're going to very carefully pour this down the side. Ooh! You know what I did? I added something in the wrong order. I forgot that oil is less. I'm spilling so much pink water, but that's okay. Huh. I made an error, my friends. Do you see that? I forgot that oil floated on water. So we now have a layer of corn syrup, a layer of soap, that kind of orangey pink layer, gross, is our water, and then I got the oil on top. So things we all learned together that I should know as an adult. Oil is less dense than water. Clean up my little spill. I should know that because of our next activity, but I digress. Doing great. Now I'm going to add the acetone. It's nail polish remover. It's just acetone. Be careful with this because it's a little more toxic. So if you're doing this with little ones, don't recommend using this one. Don't drink this anyway because barf. Just be careful because this stuff doesn't smell good and it's not really good for you. Awesome. Okay, not to use too much because I only have so much makeup remover or nail polish remover. So there we have it. There is our density tower. We've got corn syrup, soap, water, oil, and acetone nail polish remover. One thing I want to try now, so I saw this on the internets today, and I've never tried it before, so experiment time. I'm going to drop some objects in here and see where they end up. So first thing we're going to do is the bolt, just to see how dense it is. I have a suspicion, but we're going to find out. So our bolt immediately sank to the bottom. So the bolt, I think, is, we could even probably say, my brother laughing. The bolt, we can probably say, is even more dense than the corn syrup. Next, we are going to add the cherry tomato because I am curious. Given that this is mostly water, there's a good flow. Woo, that's cool. Okay, that is very cool. Sorry, I'm excited. The cherry tomato did not sink to the bottom. It lays suspended in the soap layer, which is cool. And let's do the popcorn kernel last. See how dense it is. Oh, the popcorn kernel. You can see it right there. Oh, is it actually sinking into the corn syrup? It kind of stopped at the corn syrup. So the tomato, I think we can say, is more dense than soap because it's floating in the soap, but I think we can say the popcorn kernel is just about as dense as the corn syrup, whereas the bolt is more. So this is our little density tower. You could use whatever objects you want, as long as you ask first. And you can layer whatever kind of fluids you want. Just make sure we're using safe ones. And give it a try. And if you make a cool multicolored density tower, tag us on social media. Show off. Show me. I will be hyped to see your stuff. So, our second activity today is we are going to make a lava lamp. How, pray tell, are we making a lava lamp, you ask? Well, I'm going to show you. Our lava lamp will have 3 ingredients. It has our colored water. Shocking. That's why I have so much. I guess it is 4, technically. Cup, count that as an ingredient. Good old canola oil, once again. Covering up the brand. Good old canola oil, once again. And something akin to an Alka-Seltzer tablet. So, what do I mean by an Alka-Seltzer tablet? I mean something that when you add it to water, it fizzes. So there's a couple different options of things you could use for here. Alka-Seltzer is the classic. You add it to water, it kind of works as an antacid, so it's for when you have heartburn and stuff like that. And it reacts with the water to form gas. What I am using today is I'm using denture cleaner because it works really well to clean mouth guards and retainers, which my family has the worst teeth known to man, so we all have either a mouth guard or a retainer. So we have lots of this in the house, and they will fizz when you add them to water. Other things you can use that fizz besides Alka-Seltzer tablets or denture cleaner, but these ones are probably your cheapest option, can buy them in like big packages. There's sometimes also like fizzy tablets you can add for like electrolyte drinks. Those would probably work too. But I went with the option of something I already had in my house. I guarantee you it's something that would be added to water fizzes. They work the same kind of way as bath bombs. Don't add a giant bath bomb. So, what are we going to do? 3 steps. First, water. Are we thinking that's a satisfactory color? I might make it a little more purple. Can you tell I like the color purple? I wear my purple Science Venture shirt almost every time. I have a lot of Science Venture shirts, but the purple one is just, good. Good old vintage Science Venture purple. Beauty. Okay. Pour this in our cup. And we want it about halfway full. Again, this isn't one you necessarily need to measure. It's a lot of eyeballing. Makes it a little easier. And then we are going to carefully add our oil so that it floats in a layer on top, just like I remembered earlier. Oops, got some oil on my table, but that's okay. That's why I work on the island where the surfaces are safe. I'm gonna need to get my mom some more vegetable oil, but that's okay. Kind of a thick layer. Okay, so what do we got now? I have pink fingers from the food dye. What do we have? Just like we saw with our density tower earlier, it's kind of like a 2-layer density tower. So we've got our water underneath, that's purple, the veggie oil on top. So this is the next step. This is the fun step. This is the step that is fun if you have little ones at home. The digital tablets, they smell weird and minty. What you're going to do, we'll count down. Blech. Everything I touch now is sticky. The corn syrup was used once at the start. Everything's sticky. Oh, oiled itself to the table. Okay. We are going to count down. We are going to add our tablet to our cup, and we are going to see what happens. So if you have little ones at home, this is a great step that they can do because it's fun. Okay. We're going to go 3, 2, 1. What do we see? We're starting to see some bubbles. So what we have made, my friends, is we have made our own lava lamp. So as our tablet fizzes, the gas it creates is the least dense. So it wants to float on top of the oil, but it kind of gets trapped in these bubbles of color of the water. So these float up, the gas escapes at the surface, and then we have our colored water drifting down. So this is why I wanted to make it so dark, so you can see the different bubbles. So we have successfully made our own lava lamp at home, and you can reuse this. You can add tablets multiple times. I'm probably going to add another tablet when my roommate gets home because she's going to like this. So you can use this a couple times. Well, you can see it just keeps going. Apparently my brother thinks I'm hysterical. Yeah, this is all thanks to density. So density, like we said, was the ratio of mass to volume. So if it is a higher amount of mass to volume, probably more dense than something that has less mass to volume. More dense things will sink to the bottom, so less dense things will float to the top, and temperature can also affect density, with added heat making something less dense. So, for example, other example I thought is if you've ever been in a lake or the ocean, somewhere where the water's kind of still and you're sort of floating on the top, especially like on a nice warm day and the water's kind of nice, you're just drifting, but maybe one of your legs goes a little too far and all of a sudden it's like freezing cold water and you're like ripping that leg back up. That is because the warm water, warmed up by the sun, is going to float on top because it's less dense than the cold water, which will sink to the bottom. So, our lava lamp is starting to peter out now. Thank you so much for joining me on this week of Kitchen Chemistry, week 7. What? this is the end of our classic experiments for this this sort of series. And starting next week, we are going to be back making new recipes. Probably, I think what we're going to do is we're going to have about 3 weeks of egg themes. So be prepared. Eggs will be consumed. Sugar will be involved. Potentially chocolate. It's going to be good. Anyhow, I hope you have a wonderful week. I hope you have a great long weekend coming up. Wear lots of sunscreen. Be safe. Have fun. And do some science. Okay, I will see you next Wednesday. Thanks for joining me. Bye-bye.